Hello. So, this is an enrichment kit in mathematics for grade 8 students of San Isidro National High School. So, before you proceed with this video, you are expected to accomplish the pre-assessment. Okay, so the link is provided on the description of this video. So please accomplish the pre-test first before watching this video. Okay, so let's proceed. So to be specific, so this is an enrichment kit in systems of linear equations in two variables. Okay, so since this is an enrichment kit, I'll try to teach you the systems of linear equations in two variables mixed in Tagalog and English. Okay, so let's start. So systems of linear equations in two variables, what do you mean by this? Okay, so the prerequisite topic of this one is linear equations in two variables. So before you proceed with this topic, you are expected to discussed already all about linear equations in two variables. So if you already know what is a linear equations in two variables, so it will be easier for you to understand this topic, systems of linear equations in two variables. So this is systems. This topic is basically systems plus the linear equations in two variables. So what does it mean? So let's recall linear equations in two variables. So when you say linear equation, so this is an equation. An equation is said to be linear equation in two variables if it is written in the form ax plus by equals c. So that is the general equation of a linear equation where a, b, and c are numerical coefficient. Okay, so for example, we have 10x plus 4y equals 3 and negative x plus 5y equals 2. So what are you looking for? How do you identify whether the equation is a linear equation or not? Okay, so parang tao lang yan, no? So paano malalaman kung ang isang tao ay fan ng BTS? Okay, so paano malaman kung ang isang tao ay ARMY? So let's say nakasalubong mo lang siya, so meron kang hinahanap ng mga signs, di ba? So yung mga ARMY mabilis din magkakakilala kasi pag nagkita sila, alam na agad nila kung yung kaharap nila ay ARMY o hindi, tama? So alam na nila kung makakita sila yun sa suot niya. So kung nakasuot siya ng damit na may drawing ni Tata, okay, tapos may mga keychain siya ng BTS, or yung sapatos niya ay may design ni Tata. So hindi mo lang alam na siya ay fan ng BTS, alam mo rin na ang bias niya ay si V. Tama? So ganun din sa linear equations in two variables. Meron ka lang dapat na hanapin na quality ng equation para masabi mo na siya ay linear equations in two variables. So ano yung mga quality na dapat mong hanapin? Okay, so dapat siya ay may x, may y, at may equal sign. Okay? So, hindi mahalaga kung nasa kaliwa, kanan si x or si y. Basta ang importante may x, may y, at may equal sign. Okay? So, at syempre, may constant. Yung constant, kahit anong number, pwede siya maging constant. Okay? So, kahit may numerical coefficient or wala ang x or y, okay lang. Basta may x, may y, may equal sign, at may constant. So, alam mo na yun ay linear equation in two variables. So, by the way, ang graph ng linear equation in two variables ay straight line. Linear equation. So, came from the word line. So, ibig sabihin, pag graph mo ang linear equation, ang magagraph mo ay straight line. Equation naman, galing siya sa ang root word niya ay equal. Okay? So, hindi siya pwede maging linear equation kung wala siyang equal sign. So, yun yung first na hanapin sa kanya. Okay, so that's how to identify linear equations in two variables. So, paano naman pagka may systems? Okay, systems of linear equations into variables. So, this is a combination of two linear equations in two variables. Okay, so two linear equations. So, ano example niya? So, ito. First, i-check mo muna paano malalaman kung systems of linear equations in two variables. So, check if the two equations are linear equations. So, sabi ko sa inyo kanina, basta may x, may y, may equal sign, at may constant. So, check. The first equation is a linear equation. Number 2, may x, may y, may equal sign, may constant. So, check. Okay? So, these two given equations here are two linear equations in two variables. Therefore, this is an example of systems of linear equations in two variables. Okay, another example. So, x plus y equals 5, x minus y equals 3. So, let's check whether the given equations are linear equations. So, they have x, y equal sign and constant. So, check. X, y equal sign and constant. So, check. So, both of these are examples of systems of linear equations in two variables. Okay. So, let's have an exercise. So, draw a happy face if the given is systems of linear equations in two variables, and sad face if not. Okay. So, please do this in your notebook. So, answers only. Okay. So, let's proceed with number 1. So, this is the given. 8x plus 7y equals 38. Another is 3x minus 5y equals to negative 1. So, what will be the answer here? Is it a happy face or a sad face? Again, happy face if given is a system of linear equations in two variables, and sad face if not. So, I'll give you 3 seconds. 3, 2, 1. Okay? So, if not, you can pause this, then play it again once you have your answer. Right? Okay? So, let's see what is the answer for number 1. Let's check first if the given are linear equations in two variables. So, with x, y, equal sign, and constant, check. X, y, equal sign, and constant, so check. So, this means the answer here is a happy face. Okay, very good for those who got correct answer for number 1. Okay, let's proceed with number 2. So, same direction. The given are 5x plus 2y equals 4 and negative 2y equals 11. Okay, so is it a happy face or sad face? I'll give you 3 seconds to answer, or you can pause it, right? Okay, so 3, 2, 1. Okay, so let's see. The first equation, we have x, we have y, we have equal sign, and we have constant. So check. The first equation is a linear equations in two variables. But the second equation, we have y, but we don't have x. Okay, we have equal sign and we have constant. So this means that the second equation is not a linear equations in two variables. That's why this is called two variables. Those variables that are mentioned here are x and y. So if you only have y, don't have x, therefore this is not a linear equation, is a linear equation in two variables. So therefore the answer for number 2 is a sad face, because if you want to have systems of linear equations in two variables, you must have two linear equations in two variables. Okay, let's proceed with number 3. Same direction. Okay, so these are the given. X plus 9y equals 2. 2x minus 3y is greater than 12. So I give you 3 seconds to answer. So 3, 2, 1. Okay, so let's see. The first equation, we have x, we have y, we have equal sign and constant. So check. This is a linear equation in two variables. Second one, we have x, we have y, we have constant, but the relationship symbol used here is greater than. So this means that this is not a linear equation in two variables, because it did not use equal sign. And when you want to have linear equation, from the word itself, equation has a root word equal. Okay, so number 3 is a sad face. Okay, so I hope everyone got 3/3 scores on that. Okay, so let's proceed. What is the slope and the y-intercept of each line in the given pair of equations? So this is the first activity for identifying what kind of systems do we have. Okay, so because we have 3 kinds of systems, so this is a preliminary activity. Number 1, we have 3x plus y equals 5, 2x plus y equals 9. So check. This is linear equations, systems of linear equations in two variables. So the direction here is to find the slope and the y-intercept. So how do we do that? So example, we have here 3x plus y equals 5. So in order to do it, we have to transpose this to y equals to mx plus b, where m is the slope and b is the y-intercept. Okay, so we just have to transpose 3x on the other side, so it will become y equals mx plus b. So let's try that. So transpose 3x, so it will become negative 3x, then just copy 5. So therefore the slope is slope is negative 3, and the y-intercept is 5. So that's easy, right? So let's try it with the second equation. So transpose 2x, so it will become y equals to negative 2x plus 9. So slope is negative 2, y-intercept is equal to 9. Okay, so that's how to find the slope and the y-intercept. Anyway, this is a topic already discussed during the discussion of linear equations in two variables. Okay, so if you're going to identify the slope and the y-intercept, so it will be like this. So for 3x plus y equals 5, the slope-intercept form is y equals to negative 3x plus 5. Slope is negative 3, y-intercept is 5. On the second equation, the slope-intercept form is y equals to negative 2x plus 9. Slope is negative 2, y-intercept equals to 9. So we have a remark here. So you just have to indicate whether the slope are same or different. So in this case, we have different slope and different y-intercept. Later, you're going to know why we have these kinds of remarks. Okay, so this is for number 1. For number 2, this is the answer. So 3x minus y equals 4. It will become 3x equals to y equals to 3x minus 4. Slope is 3, y is negative 4. Okay, for number 2, this is also a linear equation, two variables, even though x is on the right side of the equation. The only difference is it's already in the slope-intercept form. So you just have to copy this, then identify the slope and the y-intercept, and take note of the remark. They have the same slope but different y-intercept. Okay, next. So this one here, so the slope and slope-intercept form is y equals to negative 1/3 x plus 2. Slope is negative 1/3, y-intercept is 2. Number 2 given, slope is negative 1/3, y-intercept is 2. Okay, so take note, even though they have this different numerical coefficient for x and y, still their slope and y-intercept are the same. So same. Okay, so this one same different, number 1 different. Number 2 same different, and number 3 same. Okay, so there are 3 kinds of systems of linear equations. So these are number 1, consistent and dependent, consistent and independent, and inconsistent system. Okay, so let's identify each system. Number 1, infinitely many solutions, slopes are equal, y-intercepts are equal, and the graph coincide. Okay, so that's why I ask you to identify the slope and the y-intercept, whether they are equal or they are the same or different. Okay, so when you say inconsistent and dependent, infinitely many solutions. Okay, so as you all know, the graph of systems of linear equations are 2 lines. So when you say coincide, means that they share the same 2 lines that looks like one. Okay, combined together as if they are just one straight line. That's why we have infinitely many solutions, because the points that they share together, those are their solution. So since they become as one, so therefore all their points are their solution. So infinitely many solutions. Slopes are equal because, as I have said, the graph coincide, and of course y-intercepts are also equal. So this is consistent and dependent. Okay, number 2, consistent and independent. So this kind of system has only one solution, isa lang ang solution niya. Slopes are not equal, means they are different. Okay, slopes are not equal. Y-intercept could be equal or not equal. And the graph intersect. Okay, the graph intersect. So when you see intersecting lines, their point of intersection, this is their solution. That's why consistent and independent system has only one solution, because their solution is their point of intersection, only one point. Okay, slopes are not equal. Y-intercept could be equal or not equal. Why? When you say y-intercept, that is the point where they intersect the y-axis. Okay, so if this is the point, and this is also the point where they intersect, that means they have the same y-intercept. But this is very rare. Okay, so mostly the y-intercept are not equal. They may be equal if they intersect the y-intercept on the same point. Okay, that's the only time they will be equal, but mostly they are not equal. Okay, so this is consistent and independent. Number 3 is inconsistent, so no solution. How come, no, that they have no solution? Slopes are equal and y-intercepts are not equal. Graph is parallel. Okay, so when you see parallel lines, so that's why they have no solution, because these 2 lines can never intersect. No matter how close they are to each other, they will never intersect. Saklap, no? Okay, so slopes are equal because they are parallel lines. So same distance. So if the distance here is 2 centimeter, up to here, that will still be 2 centimeter. Okay, so same distance, always the same distance. They will never be close enough to intersect with each other because they are parallel. That's why they don't have a solution, because they don't share any common point. Okay, so that's the inconsistent system. Okay, so all you need to remember here are the slopes and y-intercept if the given are equations. But if the given are graphs, so all you need to take note on this is parallel, coincide, or intersecting lines. Oh, so let's go back to our first activity. This one. Number 1 is different. So if you take note on the definition of the 3 kinds of system, you will know what kind of system is this. Different. Okay, so that's number 1. So different slope, different. This is not dependent because dependent equal. Okay, so let's see. Independent, not equal, mostly not equal, right? Okay, and the third one is equal, not equal. So therefore, number 1 is consistent and independent because not equal, or different. How about number 2? Number 2, same, different. And number 3, same. Same is coincide. So this is consistent and dependent, right? And this one here, same, different. So when you say same, different, that's the third type of systems. Same, different. Okay, equal, not equal. So that means same, different is inconsistent. Okay, take note on this. Okay, so the definition of the 3 kinds of systems. Okay, so the first graph here shows coincide. So when the graph is coincide, what kind of system do we have? 3, 2, 1. Okay, so when you have a coincide line, that means that is consistent and dependent. They have the same slope and same y-intercept. How about this one? Intersecting lines. 3, 2, 1. So what's your answer? The answer for this one is consistent and independent. Okay, so you can pause while I am counting if you do not know the answer yet. Okay, so next we have this parallel lines. So if they are parallel, it means they are inconsistent system. Okay, so it depends on the given. If the given are graphs, so you can easily identify them whether they are consistent dependent, consistent independent, or inconsistent, right? Okay, so this one, I have this problem here, number 1 to 5. Please answer this on your paper. I'll give you 5 seconds. Okay, so you can post this. You can post, then answer this. Okay, this is, it can take 5 minutes of your time. Okay, so I assume that 5 minutes is over, so let's answer. Number 1 is consistent and independent because that is intersecting lines. Number 2 is inconsistent because parallel lines. Number 3 is consistent and dependent, coincide. Consistent and independent. And the last one is again consistent and independent, only one solution. Okay, so I hope everyone gets a perfect score. Okay, so again, please remember this. We have 3 kinds of systems: consistent and dependent, consistent and independent, and inconsistent system. The graph of consistent and dependent coincide, the slopes are equal, y-intercepts are equal. Consistent and independent intersecting, not equal, equal or not equal, but mostly not equal, okay? Number 3, inconsistent, parallel, equal, not equal. Take note on this, have a screenshot of this because this summarizes our lesson for today, okay? So determine whether each system of linear equation is consistent and dependent, consistent and independent, or inconsistent. So what you need to do here is you have to find the slope and the y-intercept of each linear equation, then find out whether the slopes are equal or not equal, and whether the slope y-intercepts are equal or not equal, okay? So you can post this while you are answering, then just play it again once you are done, okay? Approximately you need at least 10 minutes for this activity, okay? So post it now. Okay, so I assume that you are already completed this. Now let's check. So you pause and you play. Let's answer now. Number 1 is inconsistent. Number 2, consistent and independent. And number 3, consistent and dependent. Okay, so I hope everyone got a perfect score on this one. Okay, so this will be your take-home activity. You have to identify whether the given is consistent and dependent, consistent and independent, or inconsistent. Okay, so that's it for this. This is the first part only of the enrichment kit because the second part will be finding the solution of the systems. Okay, so I hope you enjoy this. I know I told you that I'm going to teach you Tagalog English, but okay, anyway, I hope you learned something new today. So good luck and God bless. Okay, wait. After this, you are expected to answer the post test, and the link is on the description box. Okay, so I hope you learn. Good luck and God bless.